This is Mr. Beck Does Your Homework, Physics Homework 25, questions 1 and 2. An object is P equals 48.4 centimeters in front of a concave mirror. This P is just another notation that some people use, but what we know is that it's that far in front of a concave mirror. That is the distance from the mirror to the object itself. So that is going to be the distance to the object is 48.4 centimeters. Its real image height is 8 times larger than the object height. So if something is 8 times larger, that means my magnification is going to be 8, but it's a real image, and I know real images are going to be upside down, so this is going to be a magnification of -8, because negative magnifications are real images, positive magnifications are for virtual images. What is the location of the image? Answer in units of centimeters. So I have a DO and an M. I know that the height of the image over the height of the object equals negative the distance to the image divided by the distance to the object equals the magnification. So what I'm interested in here is this part of this equation. So I'm given my magnification and the distance to the object, and I'm looking for the distance to the image. So what is the location of image? Let me plug in. So I've got negative of the distance to the image that I'm looking for divided by the distance to the object, which is 48.4 centimeters, equals my magnification, which is -8. Now you'll see a negative here and a negative here, so my negatives are going to cancel out. So my distance to the image is just going to be, for me, 8 times 48.4, and that will give me a distance that's positive, and that's going to be my answer. If I use centimeters in, I'm going to get centimeters out, because this is just a ratio, so you don't have to convert to meters. Now it says, what is the radius of curvature of the mirror? Well, what do I know about the radius of curvature of the mirror? It turns out that when I've got a mirror and I've got an F and a 2F, 2F is the radius of curvature of the mirror, because from 2F you might remember that light comes in and goes out at the same direction. So in through 2F, out through 2F. That's because 2F is the center of that circle, so that all rays of light that would come out of 2F would bounce right back to it, because each one of these is going to be perpendicular to the mirror. So that's got to be the radius, because that's the point that is perpendicular to the mirror no matter where I go. So 2F is the radius. So 2F equals the radius. But how do I find out F? Well, my other equation says that 1 over dI plus 1 over dO equals 1 over F. So I can solve for F using this equation, where dI I solve for over here, so this number is going to be dI. dO is my original distance to the object of 48.4 for me, and that will allow me to solve for my focal length. Remember that in your calculator you're going to use your -1 button. So I'm going to plug in dI, whatever it is, raise it to the -1. So it's either -1 or my 1 over x button, whichever button you've got on your calculator. So I would plug in dI to the -1 plus dO to the -1 equals, and then whatever my answer is, I will put that to the -1 and then say equals again. Forgive me for that. That should be a -1. So whatever that answer is, I'll put to the -1 equals again, and that's going to be the answer to my focal length. But I want my radius, and it's going to be twice the focal length. So I'll take that and multiply it by 2, and that will give me twice my focal length, which is my radius of curvature of the mirror.